So in this slide, we are going to see about the network operator. Imagine if you aren't managing one greenhouse, but 1,000 greenhouses. If you make one tiny mistake, you could ruin everything. These wish list items are the safety nets that keep the system running. Operators realized that SNMP was like driving a car without brakes or a seatbelt. They sat down and created a list of must-have features to make their lives easier and their networks safer. The first point here is the power of transactions, the all or nothing rule. So, could you get the meaning? The all or nothing. In the old days, if you wanted to change 5 settings like turning on a fan, opening the vent and dimming the lights, you sent 5 separate commands. If the third command failed because of a glitch, you would end up with a greenhouse that had the fan on, the vent open, but the lights still blindingly bright. This is a mess. Here, what is the wish is, operators wanted a configuration transactions. This means you send all 5 changes in one package. The device looks at the package and says, I can do all of these or I cannot do one of these. So I won't do any of them. It's all or nothing, ensuring the device never gets stuck in a half configured state. இது உனக்கு எப்படி புரிய வைக்கலாம்னா, ஒன்று நான் செஞ்சால் எல்லாமே செய்வேன், இல்லை எதையுமே செய்ய மாட்டேன். இந்த 5ல் என்னால் ஒன்று செய்ய முடியாது, அதனால நான் எதையுமே செய்ய மாட்டேன். This is the meaning of doing all or nothing rule. I hope you get the meaning. Okay. The next point here is the configuration validation, which is the spell checker. Humans make mistakes. An operator might accidentally type 500 degrees Celsius instead of 50 degrees Celsius for a heater setting. The wish here is, they asked for a configuration validation. Before the setting is actually applied to the machine, the validator checks it against the Yang rule. It acts like a digital bouncer at a club. If the setting doesn't follow the rules of the data model, it doesn't get in. This prevents illegal settings from ever crashing the hardware. I hope you get the meaning. The next point here is rollback, which is the giant undo button. Sometimes you apply a setting that is technically valid, but it turns out to be a bad idea for the network. Operators needed a way to dump or restore or roll back. This is like a video game save point. Before you make a big change, the rollback manager takes the snapshot of the current working state. If the new settings cause problems, you hit the rollback button and the system automatically generates the transactions needed to return the device to exactly how it was before you touched it. I hope you get it. The rollback is moving backwards before we touch the system. How it behaves before we touch the system, the rollback button works like that. Okay. The next one is distinction between config and state. The intent versus reality split. One of the biggest headaches with SNMP was not knowing if a number was a setting or a reading. This is what I have previously explained in the problems. Before 2 slides, I have explained this problem. Operators wanted a clear distinction between configuration and state data. Configuration is what I want the device to do. Set fan speed to 5. That is the configuration. State is what the device is actually doing. The state, which is example is, fan is currently spinning at 490 RPM. This is the state of the fan. The configuration of the fan is set the fan speed at 5. Okay. By separating these, operators can fetch just the settings to see if they are correct or just the state to see if the device is healthy. Okay, but the SNMP can't do this. This is one of the problems in SNMP. Okay, we'll move on to the next slide. So now that we know what operators wanted, let's look at the solution. Netconf, Network Configuration Protocol. Okay, if SNMP was a postcard, Netconf is Secure High-Speed Courier Service. Could you get the difference? Netconf is Network Configuration Protocol if SNMP was a postcard. That is a stateless protocol. SNMP can only send the messages, but we don't get any notification back. This is the SNMP protocol, and Netconf is a secure high-speed courier service. Okay, the session-based approach, which is in Netconf. Okay, we are going to see the Netconf protocol. The first point here is the session-based approach. Unlike the hit and run style of SNMP, Netconf is session-based. Think of this like a phone call. You dial the device, say hello, perform your work and then say goodbye. The device knows exactly who you are throughout the whole call. Do you get the meaning? So if you speak hello, then the receiver will speak back and talk to you. You do your work and then you say goodbye and the call ended. So the device knows exactly who you are throughout the entire transaction. Okay. The next point here is dual purpose. It is designed specifically to allow you to both retrieve and manipulate. Retrieve in the sense, see what's happening, and manipulate change settings data on your network devices. So this is for dual purpose. So you can both retrieve and manipulate data on your network devices. So using Netconf, we can do secure transaction, and that during the transaction period, both you can retrieve data and the receiver will know, also you know what is happening in the entire transaction. Also, there will be retrieving and manipulating data on the network devices. Okay, we'll move on to the next slide, explaining deeply into the netconfig protocol. In this slide, we are going to see the architecture of Netconf protocol. So this is kind of a 4-layer cake. Imagine the 4-layer cake. To keep things organized, Netconf is built like a 4-layer cake. Each layer has a specific job to do. As you know, you have studied so many architectures like the same. The Netconf has 4 layers. The first layer is transport layer. This is the bottom layer. It uses SSH, Secure Shell, or TLS. This is like an armored tunnel that protects your data from hackers while it travels through the greenhouse. Okay. The next layer is RPC layer, Remote Procedure Call layer. This behaves like an envelope. Imagine an envelope with a stamp on it. One side says RPC, which is your request, and the other side says RPC reply, the device's answer. It provides a standard way to wrap your messages. The RPC layer works like an envelope. There we can send my message, and also I can receive the device's answer also. Okay. The third layer is operations layer. This will work like an action layer. These are the verbs or commands. The first verb is like get config, which is show me the settings you have right now. The get config message get the configuration details from the device. Then the next verb is like edit config. This behaves like I want to change the thermostat from 20 degrees Celsius to 22 degrees Celsius. This is like the action we are going to perform using the edit config message. Okay. The next layer is content layer. This behaves like the data we are retrieving. This is the actual information inside the message written in XML and defined by our YANG blueprint. Okay. The YANG protocol will be explaining in the coming slides. So we'll move on to the next slide. I hope you understand the architecture. We'll explain the Netconf communications in the next slide. In this slide, we are going to talk about how Netconf communicates. How does the conversation actually happen? Netconf uses a specific framing method to ensure nothing gets lost. It uses XML encoding. Netconf speaks in XML. Why XML? Because it is structured. Instead of just saying 22, XML says temperature, the tag temperature 22 and close tag temperature. This makes it impossible for the device to confuse that the temperature with the fan speed. There will be no confusion between explaining that number is whether the number 22 is temperature or a fan speed. There will be no confusion for the device. So that is why Netconf is using XML. Okay. The next one is ensuring reliable delivery. Because it runs on top of a reliable transport like SSH, the protocol ensures that every message reaches its destination in the correct order. If a message is lost, the transport layer notices and resends it automatically. Could you get the meaning? The next one is framing. The RPC layer provides a mechanism for framing messages. This is like putting a start and end marker on the long string of data so the device knows exactly where one command ends and the next command begins. So this is how Netconf communicates. Okay. We'll move on to the next slide. This is the content layer. So you know XML is using XML encoding, right? Sorry, Netconf is using XML encoding. All the information, whether it's the temperature of the greenhouse or the speed of the fan, is wrapped in XML tags. This makes the data readable for both humans and computers. The next one is data separation. One of the best things about Netconfig is that it keeps a wall between configuration data and state data. Configuration data is nothing but what you want to happen. The state data is nothing but what is actually happening. So the configuration data lives in a special place called configuration data store. Think of this as a goal book for the device. The state data is live real-time information. The next one is architect. How do we know what the goal book should look like? We use a language called YANG to define the schema or the blueprint of that data. Okay. So the YANG is a kind of language that will be behaving as a blueprint for the data we are transferring to the device. Okay. I hope you could get the meaning, or I hope you understand the Netconfig content layer. Okay. This slide is talking about the content layer. There will be 3 points: XML encoding, the data separation, and the YANG. Okay. We'll move on to the next slide.